Hello my dear students, welcome to Unacademy GATE English. This is your Swamy Sir. So today we are going to discuss the basics of signals and systems, which is a continuation to the previous class. And before going to start, let me introduce myself. I am KV Swamy. I did my MTech in Systems and Signal Processing from JNT College of Engineering, Hyderabad, and I passed out in the year 2007. And since 2009 I was into this GATE coaching field, teaching my favorite subjects, signals and communication, throughout the country. I have total of 12 plus years of teaching experience. Now I am associated with Unacademy, and if you want to purchase any course on Unacademy, you can use my code, that is KVS Live, to get flat 10% discount. First of all, we'll see what are the courses we are going to have in Unacademy. And those who are coming new, please subscribe the channel and share the channel. As far as GATE is concerned, here we are going to have two types of courses known as Plus subscription and the Iconic subscription. In Plus subscription, the student is exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. Means if a student is not comfortable with English, he can take the class in Hindi, and if a student is not comfortable with Hindi, he can take the class in English from his favorite educator. And we have something known as rank improvement batches here. And apart from this Plus subscription, we have Iconic subscription also, in which the student will be under the supervision of a educator known as mentor. So here we are going to have personal coach, study planner, study booster sessions will be there, personalized test analysis, dedicated doubt clearing instructors are there, and preparatory study material is also given to the students. Now, hi Chinna, good evening. Now first of all, we'll see what is the fee structure for Plus or Iconic subscription. So if a student is planning to take Plus subscription for GATE or ESE for 1 year, that is 12 months, it costs around 27,225 rupees. And if you are going to use my code KVS Live, you are going to get flat 10% discount. Again, for this GATE and ESE only, if a student is planning for 18 months, that is 1.5 year, it costs around 34,650, and using the code KVS Live, you are going to get flat 10% discount. And for the same GATE and ESE in Plus subscription for 24 months, means 2 years, which is ideal for second year students. So it costs around 39,600. Again, if you are going to use my code KVS Live, you are going to get flat 10% discount. This is about Plus subscription. And we'll see what happens in the Iconic subscription. The same, if you go for Iconic subscription for 12 months, that is 1 year, it costs around 45,225. Again, if you are going to use the code KVS Live, you are going to get flat 10% discount. And this Iconic subscription for 24 months, that is 2 years, for GATE or ESE, it costs around 66,600. And if you are going to use my code KVS Live, you are going to get flat 10% discount. So this is the free fee structure, and whatever means the course, don't forget to use the code KVS Live to get flat 10% discount. Now let's jump to, or let's switch back to our subject. See, and okay, what happened to others? What happened to Vignesh, Harika? Right. See, let's start the class. In the last class, we have seen, we were discussing the basic signals, in which we completed the sampling pulse, sync pulse and all. Now, if I ask you one question from the previous, if I recap the previous class basics. So in the previous class, we have seen that we have seen the definitions of two basic signals. So sampling of t, which is nothing but sin t by t, and sync of t, one more signal. Both the signals will resemble the same, shape is same, sin pi t by pi t. Right. Now from this definitions, if I ask you one question, what is integral minus infinite to infinite sync t dt? Any answer? Vignesh or Chinna? Integral minus infinite to infinite sync t dt. What is the value of this integral? What is the value of this integral? You can type your answer in the chat box. Yes, Ravi, it is 1. Yes, Ravi. See, this is nothing but area under the sync pulse, which is nothing but 1. Already we have seen. Suppose if I ask you, can you answer what is the value of this integral? Sync of t minus 1 dt. Sync of t minus 1 dt. Yes, it is also 1, because already we have seen in the basics that area doesn't change with time shifting. Here shifting is done, but area doesn't change with time shifting. Suppose if I ask you this one, what is the value of this integral? Sync 2t dt. What is the value of this integral? Yes, Ravi, you are right. Now I want the value of this integral. Sync 2t dt. Yes, Ravi, it is 1 by 2. It is 1 by 2. Already we have seen. Yes, Vignesh, you are right. You are right. Suppose if you are having a signal x of t whose area is a, x of alpha t, area becomes a by alpha, and we know that sync t area is how much? 1. So sync 2t, integration means area will be 1 by 2, which is nothing but 0.5. Right? So this is about the sync and sampling functions, and I have given you the relationship between sync and sampling functions also in the last class. Now let's switch back, or let's switch to the next basic signal, that is continuous time impulse signal, which is very, very important. Continuous time impulse, or Dirac delta function. Continuous time impulse or Dirac delta function. Now this signal is given like this, denoted by del t, defined as infinite at t is equal to 0, unmeasurable at t is equal to 0, it is unmeasurable, so I am taking the value to be infinite, and it is 0 for t not equal to 0, and integral minus infinite to infinite del of t dt is equal to 1. Means from the second expression what I have written, we can say that area under this continuous time impulse is 1. So this is the definition. Now if you want to represent, there are in 2 ways you can represent. So first way of representing is like this. Put a dot here. So its height is infinite at t is equal to 0, and 0 for t not equal to 0. So there is one more way of representing this impulse signal. We'll see that one also, but we'll see how this impulse signal is generated. For that, you know that this is what signal? This is your continuous time unit step signal. Continuous time unit step signal. And what I am going to do is I am going to take the approximation. See, hope you are comfortable with this one. Continuous time unit step signal, we know this one. So u of t is 1 for t greater than 0 and 0 for t less than 0, and 0 what we have? Discontinuity. At discontinuity we have to take the average of the values. Now what I am going to do is I am going to take the approximation of this signal, denoted by u delta of t. U delta of t, and I am going to define this approximation like this. in a small, and see, this is u of t. Now I'm going to define the approximation of u of t, that is u delta of t. U delta of t. See, this delta is that in a small interval of delta, this signal raises to a value called 1, means the time taken for this u delta of t to take the value 1 is nothing but delta. Hope you understood. What I mean to say is the time taken by the signal u delta of t to reach the value 1 is nothing but delta. Now this is u of t, u delta of t. By looking at these two signals, can I write like this? Limit delta tends to 0, u delta of t is nothing but u of t. If this width delta becomes 0, both the signals become same, isn't it? Right. Now what we are going to do is, look here. So how much time it is taking how much time this signal u delta of t is taking to reach the value 1? It is delta time. Now I want to calculate the rate of change. I want to calculate the rate of change, or I want to, in other terms I can say, I want to differentiate the signal. My dear students, listen carefully. Very interesting session we are going to have now. Now, first of all, I started the discussion by taking the unit step signal. After that, I took the approximation of unit step signal, that is nothing but u delta of t, and defined u delta of t as in a small interval of delta, this signal raises to a value called 1, after which it maintains a constant level. Now what I want to do is, I want to differentiate this signal. I want to differentiate. So let differentiation of, so u delta of t differentiation, say I am denoting by del delta of t. So this is del delta of t. Now differentiation means, what do you know about differentiation? Generally differentiation means we'll denote it by dy by dx. Dy is what? Incremental change in y. Dx is what? Incremental change in x. So incremental change in y means what? Final value minus initial value. Incremental change in x means final value minus initial value, which is nothing but slope. So remember, always whenever you are differentiating a signal means you are finding the slope under that signal, and whenever you are integrating a signal means you are finding the area under that signal. Differentiating a signal means finding the slope under the signal, and integrating means finding the area under the signal. Now if I want to differentiate this u delta of t, it is simple if I calculate the slope under this signal, slope under this u delta of t. And what is the slope? y2 minus y1 by x2 minus x1. So what are the coordinates of this point? 0, 0, 0, 0. And what are the coordinates of this point? Delta, 1. Now from 0 to delta, if I differentiate, what will happen? From 0 to delta, if I differentiate, what is the slope? 1 by delta. 1, it's a constant value, 1 by delta, or the rate of change is 1 by delta. Now it is up to delta. After delta, what happened? It is going to maintain a constant level, and we know the differentiation of constant is 0. So this becomes our signal. This is our differentiated signal. Hope this is, you are comfortable. Again I am repeating, my dear students, because this concept is very important to understand. Started our discussion with u of t, taken u delta of t, and I am differentiating that u delta of t to get del delta of t, and differentiation is nothing but slope calculation. Now if I ask you, what is the area under this signal? What is the area under this signal? Area, this is in the form of a rectangle, no? Width into height gives the area. What is the width? Delta. Height is what? 1 by delta, which is nothing but 1. Area is 1. Now this is a case 1. When our signal u delta of t takes a time delta to attain a value 1. Say, assume that our signal u delta of t takes lesser time. So instead of delta, assume that it takes only delta by 2, a time delta by 2 to reach the value 1. See, in the first case, our u delta of t is taking how much time? Delta time to attain a value 1. In the second case, I am assuming that our signal u delta of t is taking only delta by 2 time to reach the value 1. Now in that case, what is the differentiation? Differentiation means again you have to differentiate the signal, right? So what will happen if I differentiate? What happens? What will be the coordinates of this point? Delta by 2 comma 1. So what is the differentiation? 2 by delta. 2 by delta. 2 by delta means here this will be a constant value. 2 by delta. 2 by delta will be greater than 1 by delta. So this is what I am going to get, my dear students. Delta by 2. Hope you are comfortable. Listen carefully. Now in the third case, this is second case. Third case, assume that my signal u delta of t is taking much lesser time than delta by 2. Assume that it is taking delta by 8 time. So in delta by 8 time, it is attaining the value 1. Now if, and again before that, what is the area under the second one? If I 0 to delta by 2, height 2 by delta means what is the area here? Green. Area is again 1. Now third case. In the third case, we assume that our signal u delta of t is taking delta by 8 time. So to reach the value 1. So what is the rate of change or differentiation? Rate of change or differentiation will be 8 by delta. So this is 8 by delta, isn't it? Now maintaining the area 1. Maintaining the area 1. Now as a limiting case, my dear students, as a limiting case, if you observe, if delta tends to 0, suppose if assume that in 0 time, means there is no transition in 0 time, if our signal u delta of t reaches the value 1, if 0 time, see in the first case delta by 2, after that delta by 8, after that delta by 16, after that delta by 32, delta by 64, delta by 128, so on. So if delta becomes 0, so if delta becomes 0, what happens to the differentiation? What happens to the height? If delta becomes 0, suppose if delta becomes 0, my dear students, tell me, if delta becomes 0, what happens to the height? What happens to the height? You tell me. In the first case, height is 1 by delta, second case 2 by delta, 3 by delta. Okay. What happens to the height if delta becomes 0? Type your answer in the chat box. Type your answer in the chat box. What happens if delta becomes 0? Means in 0 time, u delta of t is taking the value 1. Yes, Vignesh, very good. Infinite. So if delta becomes 0, what happens to the height? Height approaches. See, infinite means we can say that height is unmeasurable. We cannot measure the height. See, in technical terms we have to say if delta becomes 0, we cannot measure the height. So which is approximated to infinite, and still maintaining the area to be 1 only. Area to be 1 only. And what happens to the width? See, if delta becomes 0, my dear students, if delta becomes 0, here width becomes 0. Here the resulting signal for delta tending to 0, width of the resulting signal becomes 0. Of height infinite, area 1. So width is 0. So we are going to get a tall means very huge in height, very tall narrow pulse of height infinite, area 1, width 0. This kind of pulse we are going to get. So in 0 time, this will attain a value of what? It will attain a value of infinite. Observe here what I wrote. Del t is infinite at t is equal to 0. Impulse signal we are going to get. Del t is infinite at t is equal to 0, and 0 for not t not equal to 0. And area under the impulse is what? 1. So my dear students, here I can write again. So if the width becomes 0, this del delta of t is nothing but del t, which has this properties: height infinite or unmeasurable, area 1, and width 0. This is an impulse signal. In 0 time, it is going to get the height of infinite. See, some people will say that I am very impulsive. Impulsive means within short amount of time they get lot of anger. So impulsive in nature. So impulse signal means so in a small amount of time, width tending to 0, it will attain the value infinite. So this is an impulse signal. So what is the area under the impulse signal? 1. So as observe here, my dear students, as height is infinite, which is unmeasurable, what we are going to do is we are going to take area into consideration. So continuous time impulse can also be represented like this. I told you, there are two forms of representing. So place a arrow at 0, place a arrow of height of value 1. Here this is also impulse, but here 1 represents its area or strength. 1 represents area or strength of impulse. As height is infinite or unmeasurable, we can represent our impulse signal in terms of area also. Area means by placing a arrow and place 1 over this arrow, and this 1 represent area or strength of impulse. And my dear students, you have to remember one more important point, that if you are going to represent impulse signal in this fashion with area, its name also changes. Its name becomes continuous time unit impulse. If you are going to use area representation, so its name also changes. Continuous time impulse means you are representing with amplitude. Continuous time unit impulse means you are representing with area whose value is 1. Remember, if you are representing with area means name also changes. Continuous time unit impulse, and this is only the signal which can be represented with its area. There is an exception for impulse signal, that it can be represented with its area whose value is 1. So from now onwards we are going to follow this representation only. So continuous time impulse unit impulse means this representation we are going to follow. And my dear students, and I want to tell you one more point, that this is very important point to be noted. A del of t, V u of t, S r of t means in impulse signal, always remember, in impulse signal coefficient represents area. In step signal coefficient represents value, and ramp signal coefficient represents slope. Continuous time unit impulse means unit area. Continuous time unit step means its value is 1. Continuous time unit ramp signal means unit ramp means slope is 1. So remember, my dear students, that in impulse signal coefficient represents area, in step signal coefficient represents value, in ramp signal coefficient represents the slope. Very important point to be noted. Right, hope you are comfortable with the impulse signal. There are many advantages with impulse signal. You can ask, sir, why we are going to study this impulse signal? Any continuous time signal can be represented in terms of impulses. You take any continuous time signal, whatever may be the continuous time signal, you can represent in terms of impulse signal. That is the main advantage. And how you are going to take the advantage means that we'll discuss in LTI systems. For the time being, advantage of impulse signal is that any continuous time signal can be represented in terms of impulses. Right? Hope you are comfortable with this. My dear students, hope you are comfortable. Please type in the chat box. Impulse signal is a tall, narrow signal having height infinite, area 1, width 0. So as height is unmeasurable, we are going to represent with area. So you are representing with area means name also changes. Continuous time unit impulse. After this, I'll write here relation between relation between u of t and del of t. What is the relation between step signal and impulse signal? Remember this one. D by dt of u of t is del of t. If you differentiate a step signal, you will get an impulse signal. Integral minus infinite to t del of tau, running integral of impulse signal is u of t. D by dt of u of t is del of t, and integral minus infinite to t del of tau d tau is u of t. Right, my dear students, observe. Now the first one, anyway, you know, differentiation of unit step signal. Differentiation means slope calculation, but anyway there is one more consideration in differentiation that I'll let you know. But before that, let's understand how I am going to get a step signal by integrating an impulse signal. And we have seen just now, my dear students, that impulse signal is the only signal which can be represented with its area. So I'm going to take this one, del of tau. Do you agree that this is an impulse signal? So here 1 represent what? Area or strength of impulse. Area or strength of impulse. Value at 0 is infinite, but what is the area or strength? 1. Hope you are comfortable. Type in the chat box so that I can proceed further. My dear students, Vignesh, Harika, Ravi, Chinna, those who are present, you must be active in the live chat, then only I can move forward. Otherwise I'll feel like I'm explaining myself. Okay, right. Now here, if you integrate an impulse signal, how you are going to get a step signal? Here integration is performed from what value to what value? Minus infinite to t is the standard convention in continuous time. So minus infinite to t del of tau d tau. I took one continuous time impulse. Here 1 represent area strength. Now look here, 2 cases I'll observe. 2 cases. Case 1. Case 1. My dear students, if you observe, integration is performed from minus infinite to t. This t can be less than 0 or t can be greater than 0. What happens if t less than 0? T less than 0 means we are starting at minus infinite. We are starting at minus infinite, and I am coming here to integrate the signal. Now I reach this point t, which is less than 0. Now in this integration region, in this integration from minus infinite to t for t less than 0, do you have any signal to integrate? Do you have any signal to integrate for t less than 0, my dear students? No. So if I don't have any signal to integrate, what will be its integration? Del of tau d tau. What can I write, my dear students? 0. Case 2. Case 2. If you observe last class also, I told you the relationship between step signal and ramp signal. That also will prove. Vignesh, what happened? Now observe here. Case 2, t greater than 0. T greater than 0 means our t crossed 0. Our t crossed 0. Now integral minus infinite to t del of tau d tau is what? If you observe here, now in the second region, is there a signal to integrate? Yes, impulse signal is there. Impulse signal. And what we are going to calculate? Integration means from minus infinite to t, we are calculating the area. From minus infinite to t, what is the area? What is the area you are going to get? 1. Yes or no? 1. Now if I move further also, for t greater than 0, if I move further also, so from minus infinite to say this t, again I am going to get the same area 1, no? Because impulse signal is present only at 0 of value of area 1, isn't it? Now I can write like this, or in short, observe here, my dear students, I can write it as minus infinite to t del of tau d tau is 0 for t greater than 0, and it is 1 if 0 for t greater than 0 and 1 for t greater than 0. Now what is that signal which is 0 for t less than 0 and 1 for t greater than 0? What is that signal? If I take t less than, what is that signal? Can you get the generalized form for the right hand side? Yes, integral minus infinity to del of tau d tau. This is simply u of t, my dear students, because u of t is a signal which is 1 for t greater than 0 and 0 for t less than 0. That's what we proved. Observe here, compare, got the same, isn't it? Yes, Vignesh, you are right, you are right. Now this integration part, let's switch back to the previous class, which is nothing but the relationship between u of t and r of t. Okay, u of t and r of t. Observe here, in the last class, if you remember what I told you, integral minus infinite to t u of tau d tau is what? R of t, I told you. Now how you are going to prove this one? How you are going to prove this one? See, you have to integrate with signal, unit step signal. So first of all, draw unit step signal. Don't worry, everything is going to be repeated one more time also, my dear students. Many examples are there. You need not worry. So this is u of tau. Change the independent variable from t to tau. This is u of t. Right? Now we have to integrate this signal and we'll see whether we are going to get our RAM signal or not. So 0, 1, 2, 3, 4. So case 1, case 2 here also. What happens if t less than 0? If t less than 0, t less than 0 means we are integrating. So we are coming from minus infinite like this. So in the first case we are here. We halted here. Is there a signal to integrate? No, Baba. So there is no signal to integrate. So what is integral minus infinite to t u of tau d tau? Case 1 already. What is integral minus infinite to t u of tau d tau for t less than 0? Simply 0. T greater than 0. Next, case 2, t greater than 0, but we have different values. Say I reached at t is equal to 1. Case 2 I'll write here, my dear students. Case 2, t greater than 0. T greater than 0 means, say I am at t is equal to 1. T is equal to 1 means, observe here. Many students don't know how we got this integrations and all. So if you come regularly, we are going to discuss many things. I want your active participation in the class. Right? T is equal to 1. I am at t is equal to 1. So what is integration? 0 to 1. 0 to 1. 1 d tau. Because u of tau value is what? From 0 to 1, it is 1. 1 d tau. What is this value? 1. T greater than 0. For t greater than 0, suppose if my t is at 2. Suppose if my t is at 2. What will happen? 0 to 2. Again 1 d tau, which is nothing but 2. Suppose for t greater than 0 only, if my t is at a point 3. If my t is at a point 3. If my t at a point 3, so what will happen? Integral 0 to 3 1 d tau, which is nothing but, see, u of tau d tau, u of tau value, see 0 to 1 or 1 to 2 or its value is 1 now, so I am taking 1 d tau. What is this value, my dear students? 3. Now look here, I want a generalized expression. For t less than 0 it is anyway 0, forget about that. For t greater than 0, if I take t is equal to 1, look here, if I take t is equal to 1, if I take t is equal to 1, the integration value is coming out to be 1. Okay, fine. If I take t is equal to 2, if I take t is equal to 2 at instant 2, my integration value is coming out to be 2. This value, my dear student. 1, 1, 2, 2. Suppose if I take the value of t to be 3, my integration value is coming to be 3. And so on. In between also you can take 0.5, 0.75, any value you can take, you will get the same value. So what is that signal? If I join all these points, Here I am not able to draw properly, but I think you can understand this kind of signal. So which is a RAM signal. RAM signal. Hope you are comfortable. Hope you are comfortable, my dear students, with this. Right? Type in the live chart. If you integrate a step signal, you will get a RAM signal. Again, if you integrate a RAM signal, you will get a parabolic signal. Parabolic signal, that you can try anyway. That you can try. Fine. Okay, this is about integration, sir. What about differentiation, sir? Can you please explain the differentiation also? If I differentiate u of t, I am going to get del of t. How we are going to get, sir? One example or two examples, I'll explain that one also. Observe here, differentiation. Differentiation. So how, if I differentiate u of t, how I am going to get del of t? This is u of t, sir. What I told you, differentiation calculation is nothing but slope calculation. This is u of t. And before differentiating, look here, what always you must see is, observe, are there any discontinuities in the signal? Before differentiation, observe, are there any discontinuities in the signal? Discontinuities means what? Sudden rise or sudden fall. If you observe here, if you observe, there are discontinuities. How many discontinuities are there? Only one discontinuity. And after locating that discontinuity, you observe in which direction that discontinuity is going. It is going in the upward direction. Yes or no? So whenever you have discontinuity, simply place the impulse. Wherever you have discontinuity, simply place the impulse. And we know that impulse signal is represented with what? Its area. Height is infinite, but impulse signal is represented with area. See, wherever you have discontinuity, place the continuous time impulse. Now arrow means area we want. If you want area, take the final value minus initial value. Final value, it is attaining the value as 1. Initial value, it is going from 0. So what is the area? 1. So del of t. Del of t. Like this we are going to get. Suppose if there are no discontinuities, simply slope calculation. Slope calculation, my dear students. Observe here. Suppose if I have this kind of signal. If I have this kind of signal, minus 1, 0, 1. Right. Now I want to differentiate. This is x of t. I want to calculate d by dt of x of t. D by dt of x of t. How I am going to calculate, my dear students? And what I said, observe, are there any discontinuities? Yes, discontinuities are there. In which direction they are going to move? Observe, this is going in the upward direction, this is going in the downward direction. And what I said, wherever you have discontinuities, place the impulses. Now this discontinuity is going in the upward direction, place the impulse. Impulse means what? Area we want. Area means final value minus initial value you take. Final value is 1, initial value is 0, 1. Right? Now from minus 1 to 1, constant, differentiation of constant is 0. Now at 0 we have a downward discontinuity, so place the impulse in the downward. Place the impulse in the downward direction. Again area I want. Take the final value minus initial value, minus 1. From 1 it is coming to 0 na, so minus 1. So this is d by dt of x of t. If you are not comfortable, you can do one thing. X of t, how can you write? U of t plus 1 minus u of t minus 1. You can write like this. Yes or no? In terms of unit steps, already we have seen in how to write this kind of rectangular pulses in terms of unit steps. Already we have seen u of t plus 1 minus u of t minus 1. Now differentiate. Now what we have seen, d by dt of u of t is what? D by dt of u of t is del of t. U of t, del of t. U of t plus 1 means del of t plus 1 minus del of t minus 1. del of t minus 1. Right? Del of t plus 1 means what? Advanced version of del of t by 1 unit, means left shifted this impulse, minus del of t minus 1. Minus del of t minus 1 means delayed version with reversal. Here area is minus 1, my dear students. Here area is 1. Here area is 1 in the upward impulse. Here area is minus 1. And try to integrate this d by dt of x of t and observe what will happen, whether you are going to get your x of t or not. But there are some limitations in the differentiation which I'll be discussing in the future topics. For the time being, this much knowledge is enough. There are some limitations in differentiation also, that suppose if you have a periodic signal and if that has a DC component, with differentiation DC component will be lost. So that anyway we are going to discuss that in detail in future, but for the time being this knowledge is enough for you. Suppose if I take another signal of differentiation, minus 1, 0, 1, this is x of t. Now I want to differentiate this signal. I want to differentiate d by dt of x of t. How you are going to differentiate? Now what I said before going to differentiate, observe, are there any discontinuities? So there are no discontinuities here. So differentiation calculation nothing but slope calculation. From here to here, what is slope? y2 minus y1 by x2 minus x1. Slope is 1. Try t. X of t is try t. So here slope will be minus 1. So from minus 1 to 0, slope m is nothing but differentiation. So this is 1. From 0 to 1, what is slope of differentiation? It is minus 1. So this is d by dt of xt. Suppose if I calculate one more differentiation, d square x of t by dt square, suppose if I ask you, d square x of t by dt square, if I ask you, minus 1, 0, 1. And what I said, you have to observe for discontinuities. Here one discontinuity, upward, downward, here again upward. So what you have to do? In the differentiation, place the impulse at the point of discontinuity. Now this is going the upward direction, so place the impulse in the upward direction. Area we want, final area strength, final value minus initial value, 1. Now at 0 there is a discontinuity going in the downward direction. What happens if I differentiate? So I'm going to get an impulse in the downward direction. But what is the area strength? Minus 2. Final value minus initial value. Again differentiation of constant is 0. At 1 again there is a discontinuity going in the upward direction, so place the impulse in the upward direction. So area, final value minus initial value, 1. Hope you are comfortable with this, my dear students. There are many cases. What happens if I take an exponential signal and differentiate and all, we'll be discussing anyway, don't worry. Right. Type your status in the live chat, my dear students. Suppose if I take this one, yes, you know, d by dt of r of t is what? U of t, na? How you can prove? R of t is what? Tu of t. Tu of t. So d by dt of r of t is nothing but d by dt of tu of t. Use UV rule. T times d by dt of u of t plus u of t times d by dt of t. But d by dt of u of t is what? Del of t plus u of t, differentiation of t with respect to t is 1. And remember, my dear students, that we are going to prove afterwards t del t is 0. T del t value is 0. Remember, try, is very important for exam even. T del t are in discrete, n del n will come. So they are zeros. So d by dt of r of t is what? U of t. or from the shape of the signal also you can verify. Slope for d by dt of ramp signal, slope is constant, always 1 unit ramp. See, for ramp signal, this is ramp signal, my dear students. So 1 1 2 2 linear. So here if I differentiate from 0 to 1, there are no discontinuities. Slope calculation from 0 to 1, what is the slope? 1. From 1 to 2, what is slope or differentiation? Again 1, and so on. As you are moving towards plus infinite, the signal is going to maintain a constant slope of 1, so that if I differentiate a ramp signal, I am going to get a step signal. Hope you are comfortable. Right? So this is about impulse signal. So how impulse signal got its birth, right? And interesting point is, okay, I'm moving forward now. Now interesting point is, impulse signal cannot, I mean, there exists many ways in which we can generate an impulse signal. So always there is no rule that we have to get impulse signal from our step signal. Take the limiting form of step signal, and if you are going to make the width as 0, height becomes infinite, still maintaining the area to be 1. So impulse signal can be generated from many signals. What I am saying, impulse signal can be generated from many signals, or impulse signal is the limiting form of many standard signals. Very, very important point. Impulse signal, continuous time impulse signal is the limiting form. What is that limiting form? I will tell you. Limiting form of many basic signals. Means from many basic signals you can generate impulse signal. That is the beauty of impulse signal. From many signals you can generate an impulse signal. Sir, can you tell me some examples? Yes, observe here. Suppose if I take a signal like this, 1 by tau rect of t by tau, 1 by tau rect of t by tau. Hope you are all there, my dear students. 1 by tau rect of t by tau. How we are going to draw this one? Rect means rectangular pulse, we know. Means from rectangular pulse also I can generate an impulse signal. Not only from step, I can generate a impulse signal from rectangular pulse also. How? Observe here, I am taking this rectangular pulse. What is the amplitude here? 1 by tau. Okay. What is the independent variable? T. I already told you, amplitude name independent variable by the overall duration. Overall duration is tau, means this will be minus tau by 2 to tau by. Right? Now from this signal, how you are going to generate? Do one thing. Try to decrease the width. Here try to decrease this width. From tau to some, you try to decrease the width. Then if you want to maintain, now here what is the area? Here area is 1. Now decreasing the width, now what I am saying, decrease the width, maintaining unit area. So height will increase. If I decrease the width, if I want to maintain the area to be 1, definitely height will increase. It must increase. Now after that, still decrease the width, maintaining unit area, height will again increase. Still decrease the width, maintaining unit area, height will increase. As a limiting case, means if this width tau tends to 0, limit tau tends to 0. So what will happen? At last if this tau tends to 0, again I am going to get a tall narrow impulse signal of 0 width, height infinite, area 1. So it is nothing but del t. So from a rectangular pulse also I can generate an impulse signal. From rectangular pulse also I can generate an impulse signal. Hope you are comfortable. Now, sir, can you tell me one more example, one more signal from which I can generate an impulse signal? Yes, known signal. Known signal, you have studied that signal. What is that? Triangular pulse. Triangular pulse. 1 by tau tri of t by tau, if I take this one. Now, triangular pulse means this shape, no? Triangular pulse. This kind of shape will come. So amplitude is what? 1 by tau. Independent variable is t. And here, what does tau represent? Half pulse width. Half pulse width. This will be minus tau. Now again, try to decrease the value of this tau. Here, what is the area? Before that, what is the area, my dear students? Area half base into height, na? Half base is 2 tau, height is 1 by tau, which is nothing but 1. Now try to decrease this width. Decrease this width, maintaining unit area. So what will happen? Height goes on increasing. Height goes on increasing. At last, if my tau tends to 0, 1 by tau, if tau becomes 0, again I am going to get an impulse signal. So impulse signal can be generated in this fashion also. This is the third way of generating. Sir, can we generate impulse signal using periodic signals? No. See, from periodic signals we can generate, instead of impulse train we can generate, Vignesh. The signal what we are going to get is impulse train. Impulse train, because for a periodic signal there won't be any continuity. Vignesh, observe here. Let's take this paper. As you said, you are asking, sir, can I get an impulse signal from a periodic signal? It's a good doubt. I appreciate. Observe here. Vignesh, can you do you accept that this is a periodic signal? Do you accept that this is a periodic signal? Yes, this is a periodic signal. Now, if I use the same concept, if I make the width as 0, if I make this width as 0, if I make this width as 0, if I make this width as 0, what I'll get? So many impulses. So many impulses means at 0 I'll get an impulse, at t I'll get an impulse, at this is minus t, at minus t I'll get an impulse, and so on. So this is what? Train of impulses. Impulse train you will get. Impulse train. From periodic signal we are going to get impulse train. Train of impulses. Impulse train, which is used in sampling operation. Sampling operation, Vignesh. Right? Hope you are comfortable. Now, sir, can you please tell me one more signal from which I can generate an impulse signal? Yes, sir, I can tell you. So, sampling of t, a sinc of t, you know, right? Sampling and sinc functions. Yes. So, x of t is 1 by tau sinc of t by tau. 1 by tau sinc of t by tau. You can say, sir, we know how to draw sinc t, but we don't know how to draw sinc t by tau. Means, scaling is there, na? You know transformations of the independent variable, Baba. You can draw any signal you can draw. So observe here, let's draw. So sinc t, each and every basic we'll discuss, but only thing is we want crowd, which is not coming. See, if you are going to say everything for free, generally people won't come. Right. Sinc t by tau. Sinc t by tau means scaling is done. Scaling means what? In the time axis, divide each point with this scaling factor. So this is 1, this is 2, this is 3, this is -1, this is -2, this is -3, and so on. So this value is 1, no? So sinc t by tau, how it will? Sinc t by tau. How will it will look like? So which will be a, observe, this will become what? Scaling factor is what here? 1 by tau. Divide 1 by 1 by tau is tau. 2 by 1, 2 tau. This will be 3 tau, minus tau, minus 2 tau, minus 3 tau. And here 1 by tau, amplitude becomes here, this becomes 1 by tau. Now if I go on decreasing the width, tau, so slowly it will become impulse signal. So from this also we can generate, or I can write limit tau tends to 0, 1 by tau, sinc of t by tau is del of t. Okay, my dear students. Sir, can you tell me one more signal from where we can generate impulse signal? Yes, from sinc. Observe here, limit tau tends to 0, 1 by tau, sinc square of t by tau. Sinc already we have drawn. You try this one, and homework for tomorrow's class is how to draw sinc square of t. Sinc t, you know how to draw sinc square of t. So it is also del t. Right? Now there are some more signals. Limit tau tends to 0, 1 by tau, e power minus pi into t by tau whole square. This is also del of t. Can anybody tell me what is this signal? Can anybody tell me? Ravi or Harika or Vignesh or Chinna, can anybody tell me what is this signal? What is that signal? Do you know sinc signal, you know, triangle pulse, you know, rectangular pulse, you know, but this signal we haven't seen. Sir, you don't, I mean, you are not discussed the signal, but you are asking, but I am just checking whether you know the name of this kind of signal or not. In the chat box, please, my dear students, try to reply. What is this signal? What is the shape? I mean, in what shape you will get? This is familiar. If I say, are not exponential, yeah. Again, Vignesh, as you told, no, you are saying exponential. No, we can generate an impulse signal from an exponential also. Both are wrong. Vignesh is wrong, Chinna is wrong. And as you people said, so let's, why not discourage you? I'll do one thing. Let's generate a impulse signal from exponential signal also. This is not an exponential signal, my dear students. Limit tau tends to 0, 1 by tau, e power minus t by tau, u of t. This is del of t. This is an exponential, my dear students. This is an exponential signal. From exponential signal also you can generate an impulse signal, but the question of what I asked, that signal is not an exponential signal. Okay, let's see. I'm putting the blank before the class. If you get any idea, I'll tell you, otherwise I'll only reveal. Right, now there is one more signal. This is exponential, 1 by tau. Nobody is answering. Sorry, this is 2 by tau, e power minus mod of t by tau. This signal is also del t. So this signal is known as what? Any idea? Double-sided exponential. This is exponential, this is double-sided exponential. So from double-sided exponential you can generate an impulse signal. From exponential signal we can generate a signal. From sinc square you can generate an impulse signal. From sinc you can generate an impulse signal. From a triangular pulse you can generate an impulse signal. From rectangular pulse you can generate an impulse signal. And from unit step you can generate an impulse signal. But what is the impulse signal? Impulse signal is such a signal which is having zero width, height is unmeasurable, which is infinite, and area is 1. What is this signal? My dear students, any idea? E power minus pi into t by tau whole square. Suppose if I ask you, e power minus t square, what is this signal? Tell me. Pi I removed, tau I removed, e power minus pi t square. Inverse signal equation. What is inverse signal equation? What is inverse signal equation? I didn't get you, Harika. My dear students, this is, I'm giving a hint. Name starts with G. Name starts with G. Name starts with G. You might have studied this kind of, if I say distribution, if I say, you will get some idea. Distribution, if I say, you'll get some idea. Any guess? You have to think. Spelling mistake. Okay. You must be very active. We are going to discuss many things. Gaussian pulse, Gaussian distribution, Gaussian, not geometry, Gaussian pulse. Or you might have studied Gaussian distribution now, 1 by root 2 pi sigma square e power minus of x minus m whole square by 2 sigma square. Gaussian distribution, normal distribution, bell shaped curve, its shape will be in the form of a bell shaped curve. From this also you can generate an impulse signal, right? So there are many ways in which you can generate an impulse signal, my dear students. Okay, so just have an idea, right? Next, after this we'll see the properties of this impulse signal. Properties of continuous time unit impulse. This is very interesting, my dear students. First property, integral minus infinite del of t dt is 1. And what does this mean? What we are going to do? We are going to integrate. Integration means area calculation. What does this property say? That area under the impulse is 1. Area under continuous time unit impulse. Unit impulse means unit area. Unit step signal means unit value. Unit ramp signal means unit slope. Area under continuous time unit impulse signal is 1, right? Suppose if I ask you one question, can you tell me what is the value of this integral? Come on, my dear students. Minus 2 to 3, integration is done between minus 2 to 3 del of t dt. What is the value of this integral? What is the value of this integral, my dear students? Hare yaar. Vignesh, you are right. 1. See, impulse signal means it will exist at t is equal to 0. This is 1. Now you are integrating. What is integration region? Minus 2 to 3. Yes, minus 2 to 3. So minus 2 to 3. So impulse is there of area 1, right? Or what 5, Vignesh? What happened to you? Suppose if I ask you, what is the value of this integral? What is the value of this integral? Second integral, you tell me. What is the value of the second integral? I'm not seeing any answers in the live chat. What happened to you? Vignesh, 1 always. No man. Observe here. Here del t means it is present at 0. But minus 3. Wrong answer. Chinna. See, your integration is from minus 2 to minus 1. Minus 2 to minus 1. So this is your integration region. But your impulse signal is existing at what? Existing at what? 0. Does your signal lie within these integration limits basically? No. So it is simply 0. 0. It is 0. It's not 5 or something. It's not minus 1 even. It is 0. So always remember, if you want to find out the area, the signal must be within the integration limits. Then only you can calculate the area. Suppose if I ask you minus 1 to 4 del of t minus 2 dt. What is the value of this integral? Tell me. Vignesh, right. Minus 1 to 4 del of t minus 2 dt. What is the value of this integral? And I'm planning a quiz after 2 or 3 classes. I'm planning a quiz based on all the basics, so that you people will be perfect with each and every basic. Then you can play with the rest of the things. Minus 1 to 4 del of t minus 2. Vignesh. Yes, exactly. 1. Because look here, my dear students, del of t minus 2 is what? Delayed version of del of t by 2 units. But integration is performed from minus 1 to 4. So does our impulse signal lies between the integration limits? Yes. So its value, the integration value, area 1. Suppose if I ask you this one, minus 1 to 3 2 del of t minus 1 dt. If I ask you the value of this integral, come on, tell me. I'm waiting for your answers. Minus 1 to 2, minus 1 to 3, 2 del of t minus 1. You must be very fast, you are very slow. It is 0.5. Wrong answer, Vignesh. How come 0.5 here? You're not concentrating, you're not listening properly. Here del of t minus 1, always remember del of, in impulse signal coefficient represents the area. A del of t I told you. So if you are going to multiply an impulse signal with some constant k, the area of the impulse is scaled by k. What is scaled? Area is scaled. So 2 del of t minus 1 is a impulse signal, continuous time impulse signal existing at t is equal to 1 but of area 2. Now I'm asking, integration is done from minus 1 to 3. Minus 1 to 3. Harika, how come 3 amma? Observe here. Minus 1 to 3. Integrate. If you integrate, what you will get? Minus 1 to 3. Area you will get. Area is what here? 2. Or simply coefficient represents the area, na? Two it will come. What happened to you? Every day you people reply properly. Today you're not replying properly. Yes. See, always remember, if you're getting wrong answers, no problem. We are in learning stage. Mistakes will come and mistakes must come. Right? In examinations, you should not commit mistake. That is the idea. If you, whatever the mistakes are there, you commit in the class, nothing will happen. We are in learning stage now. Right. Shall I ask you one more? One more? Acha, you divided with the scaling factor. Where is scaling is done? So you said scaling factor, no? So let's go to the second property. As Vignesh said, skill. No need to say sorry. Here everybody is a learner. Here I am also a learner, but somewhat experienced. See, nobody knows, I mean, everything. What we know is a drop. What we don't know is an ocean. Right? Everybody. So we are all students of knowledge. That's it. Fine, fine. So next property, second one. Del of minus t is del of t. Del of minus t is del of t. Saying that impulse signal is an even signal. Impulse signal is an even signal. Del of minus t is del of t. So if I extend this one, what I can write, minus of t plus or minus t naught. If I replace t with this one, I can write it as t plus or minus t naught. Can I write like this? Yes. Isn't it? Suppose if I have del of minus t minus 1. How can I write this one? Means here this minus has no significance in impulse. If you take minus common, it has no significance. Del of minus t minus 1 means del of take minus common t plus 1. So this minus is not having any significance. Del of t plus 1. Right? Sir, can you prove? Sir, can you prove that this one and this one are equal? Yes, I can prove also. We know transformations of the independent variable, no? So try to draw the signal. Del of minus t minus 1 is there, my dear students. How to draw? This is a transformation involving shifting as well as scaling. First shift, then scale. So del of t is there with you. Go to del of t minus 1. Call this as y of t. Scaling by minus 1 is nothing but reversal. So del of minus t minus 1 I'll get. So let's draw. Del of t is there with you. Del of t minus 1. Okay. This is del of t minus 1. This is y of t. For this y of t, you take the reversal. Mirror image along vertical axis. Yes, I got this one. This is del of minus t minus 1. What could be del of t plus 1? Arey, both are same, man. Both are same. Both are same. Right? This is the second property. Now the third property. Scaling property. Del of at is 1 by mod a del of t. Del of at is 1 by mod a del of t, which is nothing but here scaling property. Scaling. Here you can extend this one also. Suppose if I ask you del of 2t, del of 2t, what is this one equal to? 1 by 2 del of t. Del of minus 2t is what? One by 2 del of t only. 1 by 2 del of t only. Again you can extend this as del of a into t plus or minus t naught is 1 by a, 1 by mod a del of t plus or minus t naught. This is to be remembered. Okay, fine. I think it's 8:15. I think you are having one more class at 8:30, right? Now I'll do one thing. Let's close this session here, and tomorrow we are going to look at the 2 more properties which are very, very important. Based on that, we'll solve several problems based on those properties, and after that we'll start with the basic signals in discrete time. But before that, all of you come prepared for the next class, and I'm expecting a huge crowd tomorrow. So my dear students, you can follow me on Unacademy, unacademy.com at Swamy, and you can go to my Unacademy channel and look at my special classes also. I've done many special classes on various topics in signals and systems, right? And see, you can please subscribe to this channel. Unacademy GATE, it is not GATE Telugu, it is GATE English channel. Please subscribe. Anyway, I'm going to upload my notes today in the channel, and these are the channels available. Any doubts, my dear students? These are the channels what we are going to have: Creatric EC WIN, Unacademy GATE ME Mechanical, Civil and Chemical, Computer Science, and this is our channel Unacademy GATE English. You have to make this channel as number 1. How to make? You have to get single digit ranks. Electrical Junction and Aptitude Express we have.